So what he says is, do a flame test after you wash the precipitate. You add some HCl. It may dissolve a little bit of this. It's not going to dissolve much of this. But you do the flame test. Your precipitate is still there, by the way, so it's still the same mixture of precipitates. But this barium has a green flame. I'll demonstrate in a minute. Calcium has an orange flame. That's one of the reasons we're doing the flame test there. Okay. That's all there is to it. Procedure 25, turning the page. So it says take the decantate, go to procedure 25. And you're adding ammonium oxalate. Now one of the first things you want to do is make sure that solution is slightly basic, because calcium oxalate is very soluble in acidic solution. So if it's acidic, you add, it says test the solution initially. If it's acidic, you add dilute or 5 molar ammonia until it is slightly basic. Again, you're doing it drop by drop. Okay. Then you add this thing, basic solution. Another white precipitate. And another really easy ionic equation. All you have to do is know the difference between Da and Ca. That's when I ask, for instance, what happens if you add ammonium sulfide to tin sulfide? And people write equations with antimony on that quiz you just got back. That's really interesting. I don't care about antimony, I asked you about tin. It either meant you didn't know the symbol for tin, or you had antimony in your notes and you knew that. And figured, hey, that's better than nothing. I don't know what it means, but a lot of people do that. I ask about antimony, they tell me about arsenic. That's great. You found something in your notes, but that was what I asked you. So here the same thing. If I'm asking about calcium, I expect to see barium. Okay, so that's the precipitate. And again, you can do the flame test, because if you didn't get rid of all the barium at this step, barium oxalate also precipitates. Now here, when you add the HCl, everything dissolves. And you do the flame test, and you get a much stronger flame test because things dissolve more readily. The sulfates don't dissolve in strong acid. The oxalate does, because you're making oxalic acid, which is a weak acid, so it pulls the reaction to peroxide. So you do the flame test. And then you add ammonia again to get your precipitate back. Down. And there's your reference precipitate. All you did was regenerate the calcium oxalate. Got rid of the H+. Dissolving calcium oxalate. Notice when you added the ammonia to this mixture, acid base, you make a salt. But salt contains the oxalate ion, which immediately recombines with the calcium. This flame is green, by the way. This flame is orange. It's in the book. And then we go with the decantate to procedure 26. That's the test for magnesium. It says save half of the decantate. So I don't studying my line longer. dividing it in half, and now you're doing the test for magnesium. This is procedure 26. This is going to be procedure 27 with the other half. So in procedure 26, you make it basic again with ammonia, and then you add disodium hydrogen phosphate. And you make a white precipitate. This is not the confirmatory test. This is what people always write down for the confirmatory test. And by the way, it's just magnesium, ammonium, phosphate. And the net ionic equation, this is a weak acid. You added ammonia and you had some hydrogen from here. In fact, I'll just put ammonia plus magnesium. There's your magnesium, there's your ammonium phosphate. And this plus 2 minus 2, the charge is 0 on both sides. But then he says, after you've got this precipitate, warm, gently stand, it takes a few seconds to form. Centrifuge, decant, start to decantate, wash the precipitate with water, and dissolve in HCl. So first you wash it, then you dissolve it. Don't add HCl while you're washing it because you'll wash it up right away. Okay. So all it does is convert this thing back to H3PO4. I guess I should write that. So when you add the HCl, you go towards this product because you're making gas. And the ammonium and the magnesium just sit there as ions. So after you add the HCl, this is what you have. It dissolves. Any precipitate that doesn't, you would discard. So just put an X here. You don't need to precipitate. You want to work with this decanter. These ions. Now you're going to add sodium hydroxide and magnesium reagent. And what's important is you read all the words, because right next to the magnesium reagent bottle is another bottle that says magnesia mixture. Magnesia mixture has magnesium and ammonia and hydroxide ions, sodium hydroxide. So it's a mixture of the magnesium and the ammonium mostly, but it has so much ammonium that it keeps it as magnesium, even though it's slightly basic. Okay. So don't add the magnesia mixture because you'll definitely find magnesium. So you want to add magnesium reagent. The magnesium reagent is just an organic dipara azoresorcinol. It's like the aluminon. It forms a lake with the sodium hydroxide. The confirmatory precipitate here, whoops, that's added. It's a blue lake because of this dye that's in the reagent. It absorbs on the surfaces. Remember, all hydroxides are sort of that pale, translucent white, but when you absorb the dye, it looks blue. It'll be a bright blue color precipitate because the reagent itself gives the liquid above the precipitate a bluish color. Okay. So if you don't get the blue color precipitate, it means that you probably didn't really have this thing back here. net ionic equation. So there's your precipitate. But it's with the dye absorbed on the surface of that, and you get the blue colored precipitate. Now you want to put the other half into the casserole as procedure 27, and you bake it. We finally get to bake something. People have been baking things all semester. Now you actually were asked to bake something. And the reason you want to bake something is to remove any ammonium that might be present. Because you've been adding ammonium all through this, so you're baking. I think it says add HCl. I'll find that in a minute. But you're making, which comes off as fumes. And so you want to bake it till you don't get any more fumes. That means you got rid of the ammonium. Now, what I'm debating, because we're running out of time, I always advertise in 1A we can make insoluble sodium and potassium compounds. And what I always had the students do at this step is on page 235, note 3, it gives you precipitation tests. And if you have a medium or larger, you will get precipitates. If you have trace, it's problematic. Because even though they're insoluble and will make a precipitate, the trace will not do it. Okay? So I'm going to talk about it, even because I might ask you questions about it. So what you're doing is you're baking it to get rid of the ammonium. And then after you get rid of the ammonium, you add some more HCl. And then you do the flame test. Do some flame tests in a minute. But then you bake it again. And get it completely dry. Says I'm over here in note 5 on page 235. You allow after the solution which the flame test has been evaporated to dryness, cool, and again, as I said, bake. And the reason it puts cool, what happens if you put cold water into a hot casserole?
Crack.
Buy a casserole, right? Which you don't want to do. So it says a lot of cool. Then you add 3 or a maximum of 4 drops of water. You don't want to add too much. It says swirl around, scrape it around with your clean stirring rod and everything, because there's always a little bit of white residue in there. Transfer it to a test tube, and you need 3 dry test tubes. Let me get this right. Because you don't want extra water. The first one, you put this sample and centrifuge it. That's not too hard. Then, the second one, it says take 2 drops, I think. You read that. Swish around, transfer to dry test tube, centrifuge, so you don't have any of that weird junk you get out of your casseroles. 1 drop, it says. So you take 1 drop of the solution from the casserole. And you put it in one of your clean, dry test tubes. Then it says add. I want to read you the sentence here. Add 2 drops of zinc uranyl acetate solution. URANYL. It says sodium reagent in some, but I actually have mine saying zinc uranyl acetate. Now, that means it has uranium. Uranium is always what? Radioactive. Now, outside your body, it's okay.
Think
You
so?
drink a little bit of uranium, it's like radium. You can walk through radium all day, but if you inhale it and get it in your lungs, it's going to eventually cause you to develop some sort of weird cancer, no doubt. Okay? So,
Third eye.
that's why I keep saying, don't lick the tabletop. One of our bottles back there has uranium in it. And there's only one bottle out there. You add 2 drops of the zinc uranyl acetate, the way we prepare it, by the way. I'll put parentheses because that's the uranyl ion. So you take uranyl acetate, you take zinc acetate, and acetic acid. That's my zinc uranyl acetate, and it is a saturated solution, so there's always some solid crystals on the bottom of the reagent bottle, so don't suck those up. So you have all of those in there, and it's going to react. Okay, here's the precipitate. So everybody refers to this as sodium zinc uranyl acetate. That's your precipitate. It's a pale yellow precipitate. That's the confirmatory test. Now all of these things, and I haven't checked this in about 3 years now, but about 4 years ago I was looking to see how to dispose of it, and I went to the Atomic Energy Commission, and they say anything like this you flush down the drain with a lot of water. Don't.
What?
We're going to put it into our waste bottle because we label it uranium waste, and they have special things they have to do when they dispose of it. But the official site still, well, up to 3 or 4 years ago, said not to do that. The state of California, of course, would be really upset if we did. So we don't. But make sure any of that waste goes into the sink. Into the waste bottle. Let's get it in the right place. Don't put it in the sink. Now, one of the things I always point out, people always answer this question, and I always see a 4 here for about 5 or 6 years in a row. That's because somebody couldn't read my writing. That's a 9. That's why I emphasize that. So I don't expect to see a 4 this year. But 1 year somebody said a 4, and next year I mean 1 year somebody said a 4. And I said, okay, that's whatever. But then for the next 5 years, everybody that had this in their book had a 4 instead of a 9. So they all worked from that same person that couldn't read my writing. Okay? And we could name this as a complex because it's dioxouranium 6. Okay? So we could say sodium zinc dioxouranium 6 acetate. But then we'd have to say non-acetate because we don't know how many. So I guess we could say tris dioxouranium 6. But everybody calls it sodium zinc uranyl acetate. That's the confirmatory precipitate. And as I said, all of that gets disposed into my waste jar. And obviously, if you've been wearing gloves all semester, you're really happy you've been doing that. Okay, the other part of the solution. Oh, I'm running out of time. I'll talk about that next time because I want to do the flame test because I don't want to bring this out again. So first I'll put my glasses on.